Hello guys, today we are going to discuss lead code 865, smallest subtree with all the deepest nodes. Here they have given one sort of binary tree and they are asking to return the maximum depth of the root node. So whatever the root node it has the maximum depth, we need to return the entire subtree of that particular tree. So for that, now we are going to follow to solve this approach. We are going with a depth first search approach. For like each and every node, we need to take an on a DFS function. We need to return a pair like depth and as well as the node. For the depth, it is nothing but the maximum depth of the subtree, like which rooted at that particular node. And for the node, as we know that like root of the smallest subtree containing like all the nodes in the one sort of the subtree. So we need to return the depth. So for that, right now I'm going to solve the approach here. Currently, I'm taking simply like one sort of a function that is nothing but an DFS. Inside this code, def DFS, and I'm passing the node, each and every node to be iterated, right? So for that, recursively it need to be iterated, right? So I'm checking if not node means then there is no subtree. So for that, I'm simply returning 0 and mentioning no, none of the subtree is possible. And as well as for recursive process for the left and right subtrees, I'm taking simply two variables, left depth comma left node, and I'm simply passing over the function and checking each and every left subtree node, and as well as simply as well as for the right depth left no sorry right node is equals to dfs of node dot right. Now here like left depth and the right depth are the maximum depth of the left and the right subtrees, and here left node and the right nodes are generally the smallest subtree roots that contains like the deepest nodes in the left and the right. So further, like after we need to check the both of the if it has like if the left depth and the right depth should be the same means, then like we need to simply spread across the both sides, right? So for that, current node should be the lowest common ancestor containing all the deepest nodes. So I'm simply returning like if left depth is equals to right depth, then I'm simply incrementing the left depth value, left depth plus 1, and passing the nodes into this tree. Here, like depth should be like depth plus 1. It is nothing but in moving up one level. So, a node is nothing but this is the node itself, like we are passing. Now, we are going to check like if the one side is the deeper and another side is like lower means like we need to check like if left depth is greater than the right depth, then we are going to increment left depth as well, left depth plus 1, and we need to pass the left nodes. It will go through each and every nodes present in the left subtree, and same as well as for the right we need to return. So for that, right depth plus 1 comma right node. Then now, like we can say that like here we are simply returning the deeper depth plus 1, and node should be like whether the uh, subtree of the left node or like uh, right node that holds the deepest node. So now I'm simply running the DFS from the root itself. So for that I'm simply returning the DFS and by passing from root onwards. And here we need to pass one, because why we are passing one? It is nothing but like we only need the node that it is the root of that particular smallest subtree. No, so for that we are returning only one. So now we are going to check the run test cases. Yeah, it is passed. Now we are going to check for the hidden test cases for this approach. using yeah, it is pass. The time complexity for this approach should be like a big O of n, because we are visiting each and every node only one time. So for that, big O of 1 should be the time complexity. Yeah, thank you.